So without further ado, I'll hand you over to Andy. Are you there, Andy?
Yep, I'm here.
Excellent. Over to you.
Thanks very much. Afternoon, everyone. So, as Nick said, I look after our team of industrial energy management within Verco, and Verco is generally a energy and carbon advisory company, and we work across a range of areas. And my specialist area, or my particular area, is energy and resource management, and I look after a team of engineers that does that kind of energy and resource management work at industrial sites. So typical client is Tulip, that we'll look at later. So what I want to go through today is basically the benefits of sub-metering, so some kind of key headline benefits that might help you guys kind of justify or look at ways to kind of justify metering projects. How to go about kind of deciding where to put meters, considerations for metering and data collection type, what kind of reporting you might want to get out of it, and how it can be used. And then we're going to look at a bit of a case study, which is Tulip, and in particular the site at Bodmin, for which Gavin Hunt looks after their energy. So I'll introduce him a bit later, but I'll cover the first bits off now. So I'm just going to run through a few kind of key benefits. The first is how to get. It's a good way of engaging people on site and raising awareness about how much energy you might use. That might be kind of through kind of charts or ratios or whatever, but until you measure it, it's very difficult to manage it and raise the awareness. So that graph there shows an example, which was I think a crate washer at the time, and it was just running kind of bypassing. It was just going to drain. The valve had stopped working, and they put a meter on it. They started showing the operators how much they were using, and then suddenly they're like, actually, it shouldn't use that much. And you can see pretty soon after they worked out what the problem was, and it's using much less. So, I mean, that's a very simple example, but it's a great way of kind of engaging and showing where poor performance is. But obviously, you have to have meters in the right place for that, and I'll come on to that later. The next kind of thing which you can do, depending on how you collect the data, is it's a real good way of gaining insight into your particular site or your process or your operation, to look for kind of opportunities to optimize or improve performance, which you just can't do when you've got just a monthly kind of total bill. So an example here, this just shows like a half-hourly profile for a particular type of sub-meter, and the type of analysis that you can do when you have that degree of data is you can look at kind of peaks in consumption profiles, like understand where the base load, or quantify and understand the base load, and look at opportunities for maybe reducing that at weekends or during non-occupancy times. And also you can start comparing similar times of operation and similar activities to see, do we always use the same amount of energy, water, or whatever it is you're trying to minimize. A great way of kind of unlocking some of these more operational opportunities would be benchmarking similar processes or departments on sites against either a target or just against each other, and start driving some kind of maybe either competition or just nobody wants to be the worst, and it tends to drive the right kind of behaviour. If you can say, well, most of the target or most best practice is X, and a couple of sites are reaching it, but some are not, and that kind of is a good way of driving the right kind of behaviours, certainly engaging with management. Another benefit is you can quickly identify kind of deteriorations in performance on site. It really does kind of, when you're using kind of maybe you're monitoring a system which has got multi-components. For example, this picture here shows a number of different air compressors, and they're all kind of delivering air to the same system. And so when you're just looking at individual meters or individual kind of compressors on their own, it's quite difficult to spot when something goes wrong, because they're either on or off. what this does is kind of add them all together and shows you the 3 different compressors. And what you can see there is one basically developed a fault, which meant it was on all the time. I think a diaphragm might have developed a fault. And we could quickly spot that there was a deterioration in performance, and then a replacement part was able to be ordered quickly, and then you maintain kind of normal operation. Without that kind of insight, it's really difficult to pick up those sort of things, and you might only notice it after a couple of weeks or a couple of maybe months. It's when kind of site performance has gone up or deteriorated, or maybe it's just lost in the noise, the general noise of kind of variations on site energy usage. So that's kind of really a key point, is kind of maintaining good performance. And the last one I've got here is that the right kind of metering really enables you to justify and do your kind of post-capital kind of improvement follow-up and justification. And what I would advocate is, whenever you're putting in a new project or a new kind of piece of equipment or something, is consider the metering and make sure that you can track how it's doing, and ensure that those kind of what you've assumed you'll be saving, you actually lock in going forward. So this graph here shows basically I think it's a system for some chilled water pumps, and I think we installed some VSDs on them, and that happened just at the start of that kind of graph. And there's a red line and a blue line. The blue line is the actual consumption, and the red line was the expected consumption given the kind of historical usage. And what we've shown there is that the actual consumption drops well below the expected consumption for a period of time, and we've used a Q-sum graph, so it kind of sums up the cumulative difference between these graphs over this time frame. And so you can actually see at any point how much you've saved from where you expect it to be. So it's a really good, neat way of kind of making sure you've delivered the savings you expect, and also if performance deteriorates, you can make sure that you spot it. And that's something I see a lot, is new equipment put in, performance deteriorates, but you've assumed that savings have been made. So that's just some kind of key benefits. I doubt if they're particularly much news to anyone, but I thought I'd start with that, because I'm always asked what benefit is there of submetering. The next kind of thing is that I see a lot is sometimes people are unsure where to put meters and what's the best use of meters. And metering can be quite expensive, and we're unsure of what return we might get. So it's really important that kind of there's a rational decision and consideration is given to where best to place meters. And I've got a simple kind of example here, is basically a simplified electrical distribution, so like a line diagram for a site, and it goes into kind of 3 transformers here, and those transformers may lead process areas or compressed air, refrigeration, all those kind of big users off it, and then there's kind of real sub users at like the 3rd tier. I know people will say, well, our site's really cross-fed and really difficult to kind of tease out into maybe by line or by kind of department, but it's good to kind of start putting in buckets of consumption. So typically what we look at is pick up the large areas, and then specifically the large consumers where we think there might be room for potential improvement. So I would probably always pick up, say, the transformer level on the low voltage side, so that I can quickly, if there's big deterioration, work out which supplies it might be. And then I'd be looking at the main culprits, so maybe the whole warehouse if I can do it. And then I might be going down to individual air compressor or refrigeration compressors, or if there's a big pump set, or maybe just if there's a large process area like a slicing hall or a bakery hall or something like that, I might want to pick up the main supplies for that. So things that I think I might be able to have opportunity to improve later. What I will really struggle to justify is picking up every single supply, because it's just going to become prohibitively expensive. From the outset, you really have to start thinking about what am I going to use that piece of information for, and what kind of KPI or metric will I report on, and who's going to need to use that information, and once that information is provided, who's going to take action upon it, because what you can end up doing is ending up with lots of different data points which no one ever really uses, and that's where you start kind of struggling with engaging on around the metering system, is when people have had experience of we put loads in but nothing ever happens. So you've always got to have in the back of your mind, who's going to use this, what is this going to feed, what kind of KPI can I make around this, who's going to want to look at the report, and who's going to be responsible. So all those sorts of things have to be considered when looking at a metering kind of strategy. So that was obviously a very kind of brief overview of the considerations to think about where to put meters. But then another thing is what sort of meters or will I need to use, because I have a range of technologies or types of metering available, and they range in cost and accuracy, and the output kind of options in terms of what data they might provide vary as well. So it's always worth kind of running through a few kind of key considerations when trying to decide this. So the first of all is what information do I really need in the kind of application of power or electricity? Am I really only going to use kilowatt hours, or would I want more kind of power quality information, such as amps per phase, voltage per phase? Would that be of use to me, or am I really just going to generate a report showing kilowatt hours? Because that might vary the kind of data collection technology as well as the metering technology you use, as well as the cost, obviously. In terms of a water or kind of a water application this is, or a gas, would I need one of these mag flow process meters to give me a very accurate instantaneous flow, or could the job be done with a more simple mechanical or turbine meter? Obviously there's an implication on cost again. Is there another way I can get similar information? So could I use a hot water meter instead of a more expensive steam meter? That might give me 90% of the insight. That might be sufficient in terms of driving the right behaviours, or would that kind of expensive and difficult to install steam meter really help? Some instances it definitely does, but maybe not all. Could I use virtual meters? So a virtual meter is when you use kind of a software application to maybe add some meters together, or subtract one from another and work out a balance. Could I get round the information using a kind of virtual meter of using data we already have? And kind of have installation requirements been considered? That's the other thing to think about. Do we, for instance, in the application of electricity meters, have we kind of specified split core current transformers? That means they're easier to install, reduce installation time. Is there physically enough space to install the metering? What access requirements are going to be needed? What does that mean for downtime? All these kind of things have to be kind of planned in and considered when looking at metering, and to ensure it's a successful implementation. The other thing is so that's my metering I've kind of covered off there. And now I'm going to talk a bit about what to consider around data collection.
Just before you do that, Andy, I've had a couple of questions sent in.
Sure.
Can you give examples of what types of equipment, for example, that you would say that the power quality, that the more advanced metering that you were talking about, where you can get ampemeters, the more rich data, volts, etc., what types of equipment that would be potentially useful on compared to just a kilowatt hour consumed unit?
I think normally it's kind of big areas where they might have been traditionally having trouble with another kind of issues on site. Maybe instantaneous load is an issue, so they might be close to their transformer limit, and then having that kind of amp information and all that to hand might actually allow them to work out when that kind of big load happens and kind of define it back down to kind of maybe changing the process slightly so that they don't need to upgrade a transformer and avoiding cost. There might be some bits on certainly around power quality if they're struggling on site with things like harmonics or distortion. There's lots of drives and all those kind of things on site. They might want to have a bit more of a better idea of what's happening on site in terms of power. The more kind of parameters, but normally kind of nine times out of 10 people only really look at the kilowatt hours. I think a lot of sites, a lot of people start pulling a lot of extra data, and it's great that and there's technology around to do that, but sometimes I'm not sure how much it's used, so that's why I've really put that up there, is to kind of unless there's those kind of other considerations about maximum loading and all those kind of other things that you might need to consider as a site, I sometimes don't see it or that wealth of information actually used in its kilowatts that people are using.
Okay, thank you. And then just another one for the non-engineers, a question around just clarifying what split core CTs are. Yes,
apologies. As I was saying it, I thought that might be a bit technical, but it's basically for an electricity meter, you have a current transformer. It's basically a lump of metal which changes a current from what's going through a cable to something that the meter can read, and it's basically a loop or a continuous loop of metal, or sometimes a square. So that has to go round a cable. They can come as solid core, which means that you have to kind of detach the cables and put them through, or they're split core, which means you can kind of clamp them round. So it basically makes the installation, certainly on existing plant, a lot quicker.
Okay, thanks ever so much, Andy.
Cool. Okay. So I'll continue now with some data collection considerations. Obviously, there's a bunch more to metering, there's a bunch more to this, but this is just trying to kind of tease out some of the considerations that I see sometimes people have missed, or things that I would look for when I'm going around doing these sort of things. What interval of data is required? So sometimes there's instantaneous in something like a SCADA application. That's when you've got something really kind of process critical and you need to know exactly what's happening all the time. You could then have maybe 1 minute data. Again, that's quite a high interval. Then, it could be anything, but typical ones are 15 minute, and then maybe half hourly, hourly, daily, monthly. But really kind of think about what interval data you need and how you use it for, and when you spot a problem, would 15-minute data be enough to establish what's gone on? Because the price of the kind of technology to capture this sort of stuff can change quite a bit, depending on what actually is required. So it's always worth kind of thinking about that. What kind of things do you need to pick up? Analog, so an analog would be something like a flow rate typically. It might be a temperature. It might be something that's maybe a pressure, or maybe you want it just digital, so that would be like a pulse, so that would be something telling you how many things have happened. So typically electricity meters would give a pulse every time there's a kilowatt hour, for instance. So that has an impact about what kind of data collection. So once you've worked out kind of what kind of signals and outputs you need to pick up, and what interval data they need to be, and you've kind of almost also have an understanding of physically where they all are relative to each other, you then might want to consider whether a wired or wireless technology is best, or maybe a combination of both, depending on the actual kind of application. So maybe if you've got lots of electricity meters in one area, wired might work out best, and then if you've got, in addition to that, a load of remote water meters stuck everywhere, which you don't want to run cables to, maybe some wireless as well. So you don't have to go one or the other, you can have a combination. Okay, that kind of says, yeah, depending on number, location, type of meters and the existing infrastructure on site. You want to think about how easy it is, or the scalability of the selected system. So that is something probably one of the most important points up on there is typically most sites we work with, they start off with, they call it a pilot or trial phase. They might have say 10 meters, and then over time they'll quickly add to that when they get the hang of it and start using the data to unearth kind of, actually, if we had another meter there, then that would unpick this, and that might lead to more optimization. And that's certainly what Bodmin has done, and Gavin will talk through that in a bit later. And then where's the data going? Do you want something on site? There's a lot of kind of cloud or web-based solutions now. They're more and more common. So that's something to think about. I mean, it's sometimes personal preference, but it could be something that you want to think about from the start. So, is there any questions on the data collection before I go on to reporting, Nick, or are we okay?
I just had one in terms of use of wireless on site. Do you tend to get many problems with interference, or do the signals tend to go through pretty much anything?
Again, probably Bodmin's a great example for this, because they've got a wireless system and they've got a very long, thin site. So it wasn't ideal, but with use of repeaters and boosters and things like that, the technology is getting better, and we don't really have problems at all now. I mean, if I did this, say, 5 years ago, I'd have said, yes, there can be quite a lot. Certainly we're onto concrete and all that kind of thing, but it is getting better, and I wouldn't say there's many problems now. So some sites still. Been doing some work at a site in Africa, and it's made out of very, very thick concrete with lots of standing bodies of water around, and we've struggled a bit there. So we've gone for a mixture of, say, wireless and wired there.
Thanks.
So reporting is the next thing. So that's, I mean, this is kind of the key point, I guess, of all this effort for metering and data collection, is that you need to turn that kind of data into some kind of usable information, which will then turn into, make people either work out where to use less, or spot when they're using more, or kind of just generally actually deliver some savings. So as long as from the outset the metering and data collection systems are considered a tool and not just a project where they will deliver 3% saving, then we're off to a winner. So thought always needs to be given to how data can be used. This could be as simple as a spreadsheet, but really, I mean, the things we've been talking about are kind of automatic data collection. So there's a range of kind of softwares out there, and reporting options, and we have one, but I mean, there are a lot. So you basically just need to think about who needs what and when. There are a couple of kinds of types of report that we have and issue to kind of clients that help them use their kind of energy. So a typical one up there is a red, amber, green kind of report in the top right. It shows kind of a consumption against target, and then a variance, and then a red, amber, green. So that's one type. You can have kind of banded displays or matrix reports. So you show kind of multiple time frames against each other for different sites, for instance, and then showing them whether they're hitting target or not hitting target. So, I mean, they're just some kind of types of reports to think about, but there's more, and generally, if you can think of a report, there's generally something offering you that report if you need it. So, but it's worth thinking of up front, and that might have a influence on what metering you think is important straight up front. So, I'm
just before you move on to the case study, Andy, just a couple of questions on reporting.
Yeah.
Someone's mentioned that they've seen some software that can stream a visual display into staff canteens, for example, on a plasma screen or a flat screen TV. How are those things built in, and have you seen those used effectively? And then second question, in your experience of working with different reporting systems, and the complexities of, as you say, people maybe collecting too much data, in your experience, which tends to be the most easy to understand and then put into action and for good use, as it were? Okay,
so the first question was about kind of display screens. They are a useful tool, I think, for engagement. as long as they're used in the right kind of sense and don't go towards the gimmick end of the spectrum in terms of, but they can be very useful, showing kind of where you are, where your target is, and some kind of either kilowatts or pound signs or something like that. Yes, they can be. Typically, they're kind of on either one or two ways. The site might have a program which they kind of automatically update the content from that, and they look at a directory for where we can, or data is provided to update it. So that's one way. Or there's like a separate kind of standalone kind of reporting thing which is connected up to the internet effectively to kind of automatically update. I think I have seen them used effectively, and they are worth considering. And then also down to, like, you start seeing more often now, like down to a line level, or a department level, or something like that is also probably the next step. The other question was around the most effective reporting type, I guess. So I think simplicity kind of wins normally. People get sent a lot of information, and they kind of, it needs to be simple. So what I find most effective is setting up, say, types of report, sending it to different people. So key stakeholders might have different need for different data, so they might only need to look at 3 different things, but make sure that you only send those 3 things to that person. And then something that just says what you've used and whether you're good or bad or close. So kind of red, amber, green, just a simple way of indicating what they are on, say, some of the top 5 metrics that they need to know about, or maybe just 3 or something like that. But limited amounts of information sent to the right person who can easily understand it is probably the best way to report. Whether it's on a table, whether it's a gauge that goes up and down, whether it's a box that different changes colour, I mean, that's personal preference really, but the message is the same.
Thank you.
Okay, so I'm now going to go on to Tulip. I'm just going to introduce kind of what Tulip has done at a group level, because we've been working on them for a while, and then I'll introduce Gavin to talk more specifically about the practicalities of what he's done at his site in Bodmin, which is the biggest energy user within Tulip, so or Tulip UK. So for those that don't know, Tulip's a food producer in the UK, basically producing a range of fresh and cooked pork products along with some other things, producing brands like Danepack, Adams, Tulip, various sausages, Spam, Stag. They have 16 sites across the UK, and over about 4 years ago they've started the journey with automatic metering and it's our carbon desktop system, and that's been rolled out across all the sites now. They use it for kind of environmental reporting as well as on-site monitoring and targeting. Back in 4 years ago, I think 2010 probably, they started with just a fairly simple system across all sites. We basically made manually entered data going into each from each site, and then we kind of automated the main incomers, and then we kind of started with a few sites on automatic metering, and then we rolled that out as well. So it's been a phased approach. And I mean, in the last few years, they haven't just put metering in, they've been quite actively working on benchmarking, target generation, as well as trying to kind of set up cross-site working groups, or clusters that they call them, to kind of be a platform where they can share best practice and learnings and good ideas, and get the right engineers in the right room from each site just to kind of share learnings. The right here is a typical type of report that we show for, that's like the main board report. It goes to the board, showing each site their performance for their key main 3 utilities, which is water, energy, electricity and fuel, be it gas or oil. And that's just with the red, amber, green kind of report, and that's a monthly report. So they did a good job of kind of getting senior level engagement, and then they kind of rolled that out. Just a quick thing on the targets, 20% reduction by 2015. I mean, these are all quite short term, close now. 15% reduction by 2015, and then 0 landfill by 2015. 15 as well. That's all based on a ratio. These are slightly out of date now, but they've kind of achieved about an 8.3% reduction on energy and 13.2% on water. But I think these are about this is probably for year 13. So they're kind of on the glide path there. So, and it should be said that most of these reductions were done by kind of optimization and fairly low cost opportunities. So now I'll just introduce Gavin. Gavin is the kind of energy manager for the Bodmin site, and he's been, well, I worked with him initially, and then since then he's kind of taken on the mantle for kind of energy reduction at Bodmin. So over to you, Gavin.
Thanks, Andy. Hi everybody. I work in the Bodmin site for Tulip. I'm down in Cornwall. We make a variety of products: cooked ham, sliced beef, chicken, turkey, and cooked bacon products. We do around 600 tonnes a week. Obviously, electric, gas, and water. We're big users. 400,000 kilowatts of electric, 550 of gas, 2,500 tonnes of water a week. Obviously, it's been an interesting journey. From the start, working with Andy, around 2010 we started. Started looking at installing meters across site. Obviously, it was a big site and it wasn't easy getting the plans in and working out where we're going to put them. Obviously, 4 years down the road, we've now got 65 meters, automatic meters, a meter every 15 minutes. We then got a lot of virtual meters set up, so you combine complete compressor usage from one area, three meters added together, give you one virtual, and we've got 30 manual meters across site. The main thing is obviously metering the big users, and obviously the key thing with installing the meters was targeting areas or processes, so you can try and break down the processes of the site. Looking at the big users, large cookers. We've got some really big gas cookers on site. Use a serious amount of gas. We've got a microwave on site. Uses a lot of electric. So it's really breaking the site down into its elements and its processes. And then once you've targeted the areas, move on to the wings of big users. Once you've got all the information coming into the system, the key thing is set up the reports and target reports. Obviously, it's great having the information coming in, but we need to use it and send it to the right people. So what I've done is set up an overall metering system for the site and reporting the key factors from the information we're getting, and send it to the right people. I'm sending an overall department and site utilities usage to directors and area managers, and then independent areas are only getting their individual department usage for water, electric, and gas. And then there's key areas within that as well. One example is we've got one manager in our raw meats processing area. He's in charge of making the brine. We use around 50 tonnes of water a week going into the brine, and obviously he's not on site 24/7. So he gets a report every morning around 7 o'clock from the previous day's brine usage. So obviously you can monitor what we're using and the volumes of brine we're going through. That's the key thing with reporting. Is the main thing is getting the information to the people that need it, not filling up everyone's inboxes with information they don't need, so on. This is an example of where we've used the data, try and focus on where we're using it and what's going wrong. This is picked up on the main water incomer, total site water consumption, and started to go out of control. You can see on the graphs it went out of control, started to rise up. So through submetering, we investigated down through the meters and pinpointed the cooked bacon department. We used a lot of water on its double D oven. It was using around 5 cubes an hour through the flows of the weirs of the oven. So we thought at the time that it was to do with a new element in the machine was being commissioned. So once the machine was finished commissioning, the fault was still there. So we started investigating further into the machine. We found that some restriction flow nozzles weren't working properly. We fitted some new restrictors, and it obviously made some big differences. We've got the machine back down to running around 2.5 cubes an hour. But then what we did was we continued to monitor and look at the usage. And I think I set a report up for that one for daily for myself and a couple other key members to monitor it and keep improving. And obviously we've dropped drastically now. We're down around 2 cubes an hour, which is drastic steps from where we were. Another one that we've done is monitoring the compressed air across site. Obviously, compressed air is a really expensive utility. People think that air is free and use it whenever they can, but it's not. It is one of the most expensive things to produce on site, bar steam. So what we've done is we've lowered the pressures across site. We've had leak surveys carried out, and obviously had the leaks repaired, and we made some big steps and improvements with the running the compressors, and also the standby and duty of the compressors. And it's ensuring that if you've got 4 or 5 compressors running one department or running your site, it's ensuring they're not all starting up at the same time. Have them staggered. And the good thing with having the Carbon desktop system is you've got data to interpret, and depending on how you set something up, you can see whether it's making a big difference or not so great a difference, or sometimes maybe even making it worse. But because you've got the data, you can then make steps to move in the right direction, which is a great thing. The last one is refrigeration electric usage for our uncured department. We fitted basically a smart control system which controls the fans in all the evaporators in the area. When the temperature within the rooms is reached, normal standard refrigeration systems, the gas shuts down, but the fans continue running. So basically, this system senses when the temperature's been reached, and it shuts the fans down. The fans then start up once every hour to recirculate the air around to make sure the room temperature is correct. And if not needed, it shuts down again. If it is needed, obviously the system starts up and chills the room down again. So, in all, it's been a great journey. It's been really interesting, and we've made some big steps in improving things on site. But there's still a lot more to go for, especially as technology improves. And it's been really interesting. Andy, back to you.
Thanks, Gavin. I've just got one summary slide now, so I'll just do this, and then if there's any questions, I guess, for Gavin, we can just do that. But I guess the key few things, if there's a few kind of salient points that we need to just take out, is that certainly for Bodmin, senior management and site team buy-in is essential. It's really difficult to get kind of people using and looking at the data if there's not a senior management buy-in. Have a defined reporting need for any meter or that you install. Ensure that any kind of data collection technology is easy and straightforward to expand and not too costly. Consider how to use benchmarking and target setting to make sure you're driving the right kinds of behaviours at sites or departments. Phased approach will kind of allow you to kind of help with getting people bought into it. If you start demonstrating some improvements, then there's more likely it's easier to justify further metering and optimization kind of potential. when a saving's been made, it's always kind of then important, maybe a few months or 6 months later, is to review the target that you've got set for that, so that you ensure that savings are locked in and you would spot any deterioration in performance. Otherwise, what we found at some sites is that they put some technology in, and over time it just regresses, the performance regresses. And then remember, obviously, energy management is quite a large behavioural activity, and the metering and reporting systems are tools. So you really need to kind of make sure that there's appropriate resource available to kind of drive the kind of behaviours and sustain the